Hi, welcome to Mommy's Academy. This time we'll be dealing with trigonometric identities, and we're going to have this in series. So in this video we're going to take on trigonometric identities series 1. So let's go. So let's have rectangle to tell or explain the trigonometric identities that we need to solve. So let's label the angles of this triangle. Let's label angle O, angle B, and angle N. So let's take this angle to be theta. We already know this is a 90 degree. So let's label this to be Y, side X, and whatever the value of side Y and side X is, let's take our hypotenuse to be 1, so that it will justify whatever the value of X and Y is using Pythagoras theorem. So let us begin to see what we can do with this triangle and the identities that we have. Now, using Pythagoras theorem, using Pythagoras theorem, we can tell that x is equal to cos theta. What do I mean? Remember that cos theta is equal to what? Adjacent all over hypotenuse. The adjacent here is x, and the hypotenuse here is 1. Hence, cos theta is equal to x, as x is equal to cos theta as 1. Using the same Pythagoras theorem, we can tell that y is equal to theta. How? Remember that sine theta is equal to its opposite all hypotenuse. So since the opposite is y, the opposite here is y, over the hypotenuse here is 1. Then we can tell that y over 1 is still y. Therefore, sine theta is equal to y. Let's take that as equation 2. So let's see. From 1, we can tell that cos squared theta is equal to x squared. That is just squaring the both sides. Let's take that as our 3. From 2, we can also say sine squared theta is equal to y squared. Let's take that as our 4. Now, add 3 and 4. Add equation 3 and 4. So, I mean equation 1, 2, 3 and equation 1, 4. So if I had, I would definitely have cos squared theta plus squared theta equal to x squared plus y squared. That is correct. We've not changed anything. We've not changed any identity. So now let's look. What is x squared plus y squared? Using Pythagoras theorem. Using Pythagoras theorem. Tell that x squared plus y squared is squared to 1 squared. How did I get 1? Remember that Pythagoras theorem says that hypotenuse squared is equal to the sum of the adjacent squared and the opposite squared. So the opposite squared and the adjacent squared, the opposite squared and the adjacent squared is equal to the hypotenuse squared. Since hypotenuse is 1 and the adjacent is x and the opposite is y, so we have x squared plus y squared equals to 1 squared, and that gives us x squared plus y squared equal to 1. So if x squared plus y squared is equals to 1, so substitute the value, substitute the value of x squared plus y squared 2 into cos squared theta plus sin squared theta. So cos squared theta plus sin squared theta, which is equals to x plus y squared, becomes cos squared theta plus sin is equal to, if this is our fifth, let's call it fifth equation. So let's take this to be our sixth equation. So that is our sixth equation. This is one of the identities that we need to learn. So at the back of our mind or at the front, anywhere we can keep it to always remember, for we'll be needing it in time to come in other videos that we watch here. So cos squared theta plus sin squared theta is equal to 1. So let's do something else with this. Divide both sides. Divide both by cos squared theta. So when we divide both sides by cos squared theta, it becomes cos squared theta all over cos squared theta plus sin squared theta all over cos squared theta equal to 1 all over cos squared theta. So cos squared theta divided by cos squared theta becomes 1 plus sin squared theta all over cos squared theta sin squared theta all over cos squared theta is equals to 1 all over cos squared theta. Comes 1 all over cos squared theta. So what would this be? Recall that tan theta is equals to sin theta all over cos theta. So is tan squared theta equals to sin squared theta cos squared theta. So let's see how we can substitute sin squared theta all over cos squared theta to be tan theta. So it becomes 1 plus squared theta equal to 1 all over cos squared theta. 1 all over cos squared theta. So this is another idea that we in our mind. It's another constant quantity that we should keep. So this is also one. And the final stage is that. So let's take that as our equation 7. Equation 7, let's keep it at the back of our mind. What else can we do with it? Let's take equation 6 again. Divide equation 6 by theta. And remember what equation 6 is. Cos squared theta plus sin squared theta is equals to 1. So cos squared theta plus sin squared theta is equal to 1. So when we divide both sides by sine squared theta, we have sine squared theta over sine squared theta squared theta. So what do we have? This is cos squared theta all over sine squared theta. Inverse of is the inverse of tan squared theta. Remember, tan squared theta is sine squared theta all over cos squared theta. So you can do a lot of manipulation from there. So this is 1 all over squared theta plus this is sine squared theta all over sine squared theta. That is just 1 equals to 1 all over sine squared theta. Recall that sine theta is equals to opposite over hypotenuse, and the inverse of theta is hypotenuse opposite, and this is equals to cosec theta. That tells that the inverse of sine squared theta is cosec squared theta. So this is cosec squared theta. So this is another identity that we should hold dearly in our art for future uses. So let's take this as identity, or let's say equation 8. Also, from this we can still do something. Let's take it again. 1 all over tan squared theta plus 1 is equals to cosec squared theta. Recall that theta is equals to opposite all over adjacent. The inverse of tan theta is equal to adjacent all over opposite, and this is cot. Adjacent all over opposite is cot. Cot theta is equals to adjacent all over opposite. So that is to tell that cot theta, is equals to 1 all over tan theta. Should that be the case, cot squared theta is equals to 1 all over tan squared theta. What happened to the 1? 1 is also carrying square, but 1 squared is just 1. So what I did was to square both sides, so that cot squared theta is equals to 1 all over tan squared theta. So since I have 1 over tan squared theta here, I can substitute it to be cot squared theta plus 1 is equal to cosec squared theta. To our art, and register it for further references. So this is another one. So let's take it to be 9. Identity number 9. I hope you understood how we derive all these identities one after the other, from simple to what we have on our screen. I believe you understood everything perfectly. Watch carefully, get them into your memory, and watch the next series. Bye bye. See you in the next